Alright, this is page 5 of your review sheet. Write an equation for the height of a projectile launched at 60 miles per hour from 5 feet high launch pad. Alright, so the first thing that we have to know is, remember your equation is h is equal to a negative 1/2 g, which is your gravitational, t squared, which is your time, plus your v sub 0, which is your initial velocity, times time, plus h sub 0. And if your gravitational is feet, you would use 32 feet. And if your we're talking about meters, it would be 9.8 meters. Alright, since we are talking about feet, we're going to be using gravitational feet. So I just want you to write an equation, so you're just going to plug in the numbers. So h is equal to negative 1/2, and g, we're using feet, so we're going to go 32 t squared plus our initial velocity of 60, and we have t, and our initial height is 5. So we just have to clean this part up right there. And we have h is equal to a negative 16 t squared plus 60 t plus 5. Alright, solve it out. So we have to solve these equations. So because, see how there's a square there and there's no other variable, you can actually just take the square root of this. So I'm going to take the square root of both sides, and that square root would get rid of that. So you have x minus 5 is equal to plus or minus the square root of 16. What is the square root of 16? 4. So you would add 5 to both sides. So x is equal to 5 plus 4 and 5 minus 4. So 5 plus 4 gives me 9, and 5 minus 4 gives me a 1. So that means that x equals 9 or 1. Alright, now you could have multiplied it out and then used the quadratic, which is fine. However, if it's already, like if you can get the square by itself on the one side, you can take the square root. On this one, see how the square is not by itself? You must multiply it out and use a quadratic. So you have x times x is x squared. What is x times 1? X. And then I'm going to bring this to the other side because the quadratic has to be set to 0. So we're going to go minus 1 is equal to 0. Remember that in a quadratic, a is in front, the coefficient in front of x squared, b is the coefficient in front of your x, and c is the one that stands by itself. So a equals 1. What does b equal? 1. And c equals negative 1. Okay, I want you to tell me what the quadratic is. Can't hear you. Negative b plus or minus the square root of b squared minus 4ac all over what? 2a. Very good. Alright, so now we're going to plug in the numbers. So we have negative b. Negative, remember, always means opposite. So since it's 1, it's going to be opposite. So negative 1 plus or minus the square root, b squared, 1 squared is 1, minus 4, and a is 1, and c is negative 1, all over 2a, which is 1. Well, let's clean it up. We have negative 1 plus or minus the square root of, right here we have 1, and a negative over here is positive, so that's a 4. So we have 1 plus 4, which is 5, all over 2. Since the 5 cannot be reduced or anything, or it's not perfect, that's the answer. Alright, on C, see how there's a square and there's no other x? What I do is I always bring the 25 to the other side. Yeah, you could use the quadratic, and then b would be, what would b be if we used the quadratic on this? B would be 0. That's right, b would be 0. So what I'm going to do, though, is I'm just going to bring 25 to the other side. So I have x squared is equal to a negative 25. And then what do I have to do? Take the square root. So my x's are gone. So I have x is equal to, the square root of a negative number is I, and then the square root of 25 is 5. So we have 5i. But also remember, when you take the square root, it's always plus or minus. That's why in the quadratic it's plus or minus up there. Alright, D, we're going to bring 6 over to the other side, so I have 10x squared minus 7x minus 6 is equal to 0. Alright, now what do I got to do? The quadratic. Yes, the quadratic. So now I have A, what does A equal? 10. Very good. B equals negative 7. And C equals negative 6. So, negative B means opposite of B, so we have 7 plus or minus the square root of B squared. Negative 7 times negative 7 is 49. Now I like to just write that out, because if you want to say the negative 7 squared, a lot of times that gets entered into the calculator wrong. So I know what negative 7 times negative 7 is. I'm just going to write it down. Minus 4a, which is 10, and c, which is a negative 6. All over 2a, which 2 times 10 is 20. So I'm going to actually write that out too. Alright, so now we have here, you can take your calculator and I'm going to clear this out. Now I'm going to put this all in my calculator right there. The 49 minus my 4 times 10 times negative 6, which is 289. So that means I have 7 plus or minus the square root of 289 all over 20. Now, I kind of want to make sure, I want to first of all check to see if 289 is a perfect square. So I'm going to go second entry, 289, and it is 17. So because this is perfect, I know I can just go through. So now what I have is I'm going to have 7 plus or minus 17 over 20. So I'm going to go 7 plus 17 and then divide that by 20 and put that into my fraction. So that equals 6/5, or 7 minus 17 and divide that by 20, which is 0.5, and we all know that that's 1/2. So I'm going to squeeze this in down here, I think, or I can open it up. I'll open it up and put it right here. So it's either so I have 6/5 or a negative 1/2. So those are my answers, because those have 2 answers. Remember, if your discriminant is a number, then you're going to have 2 answers. If it was 0, then you would have had, if it was 0, you would have just had the one answer. And if it's negative, remember it's imaginaries. Alright, let's go to 19. It says, which of the following are real numbers? Now remember, real are everything but imaginary. So negative 2/3, that's a real number. I, that's imaginary. So see how imaginary is down there? I'm going to put it down there. Imaginary. 17 is real number. Pi, that's a real number. The square root of -1, what do you think that is? Right, it's imaginary. So the square root of -1, that's imaginary. Then we have the square root of 45, that's real. You have 3 plus I. See how it has that I? That means it's imaginary. And then the square root of 36. Alright, so now the reals we have to break up into, are they rational or irrational? Remember, rational can be written as a fraction. So if it can be written as a fraction, then it's rational. If it cannot be written as a fraction, it's irrational. And things that cannot be written as a fraction would be non-repeating decimal. Alright, so negative 2/3, well, that's already in a fraction, so we know that's rational. 17 could be 17/1, so that's definitely a fraction. Pi, well, if we don't know pi, what we'll do is we'll go here, we'll clear it out. It goes second pi, or where's my pi button first? Yep, over here is pi. And we have a whole bunch of numbers. It's 3.1415925654. See, it's not repeating, so that can't be written as a fraction. So if you push your math fraction button, math and then fraction, it's going to give you that same number back. So we know that that's irrational. Alright, so now we're at the square root. So we have the square root of 45. So again, if we push our math fraction, it's going to give us the, see how it's non-repeating, so that means that it's irrational. And then we have the square root of 36, which is 6. And I don't think it, yeah, it won't go 6/1, but you know it can be written as 6/1. So square root of 36 is rational. Alright. Here we go. Alright, it says, give the number of solutions of the following. Find the discriminant. So remember the thing that's under the quadratic over here? This was the discriminant. This is the discriminant. And again, if it is 0, then you'd only have one number, right? Because negative b plus or minus 0. If you go negative b plus 0, you're going to get the same number as negative b minus 0. So if it's 0, remember, and I'll write that down here, if your discriminant equals 0, then you have one solution. That also on a graph tells you that you have one x-intercept. If it equals a positive number, then you have two solutions, right? Because up here, right here, see how this is it was the square root of 289. 289 is the discriminant, so we ended up with two answers. So you have two solutions, and it also tells you have two x-intercepts. And then if you end up with a negative number, you have no real solutions because it says real solutions. Because we know then that our solutions would be imaginary. Alright, so let's find out what it is. So remember, what we're looking at is just the b squared minus 4ac. So we have here b, which is 12, so negative 12, but when we do negative 12, so remember it's going to be negative 12 times negative 12, so that's your 144. If you just did negative 12 squared, you're going to get a negative 144, and we know that's not it. So that's why a lot of times I just go 12 squared, because it's going to be a positive number. So b squared minus 4a, which is 4, c, which is 9. So that gives me 0. So the number of real solutions, I'm going to have one solution. Alright. So b, again, I have b squared. So that means I have 3 squared minus 4a, which a is there, is your 2. And then c, which is 4. So I have 3 squared, 9, minus 4 times 2 times 4 gives me a negative 23. So how many real solutions? I have none. I have no real solutions. Because I know that I'd have two imaginary though. But that's not what they want to know. And then the last one says that we have x squared minus 9x plus 8. So I still have b squared. So I have negative 9 squared is 81 minus 4a, which is 1, c, which is 8. So I have 81 minus 4 times 8, and I get a 49. So that means I have two real solutions. It also tells me that I have two x-intercepts. And on this one, since I have no real solutions, I have no x-intercepts, because x-intercepts you get the same amount as your real solutions. Alright. 21. It says, refer to the parabola graphed at the right with a vertex of 6, 3, so this is 6, 3, and the directrix of y equals negative 1. And f is not drawn to scale. That means that this is not the position of f. So f could be somewhere else, somewhere, right? So they want to know where f is supposed to be in the true definition of the parabola. So the first thing you have to know is that pretending that f is in the right position, if it was, FB would equal what? It would equal the same distance, so the point on the graph, so F to the point on the graph, so the focus to a point is the same distance as that point to the directrix. So you have to go straight down, and since this is the directrix, it would have been BH. Alright. Then it says, what are the coordinates of the focus? And don't just do it by looking at it, because remember, it isn't drawn to scale. But remember, from the focus to the any point, so we're going to say the vertex, because remember the focus is on the vertex. So the focus to the vertex is the same distance from the vertex to the directrix. So I want you to take a second, and I want you to tell me how much is between your vertex and your directrix. Alright, so how much is there? How much is between your x-axis and your vertex? It's 3, right? And then from your x to here is 1. So if we have 1 here, because it's y equals -1, so if we have 1 here, 3 there, that means it's 4 total. So then we have to add 4. We have to move this point, our vertex, 4 units up, because that's where our focus will be. So if we have 6, 3, and I want to add 4 units to move it up, so that means my focus will be at 6, 7. And the reason why I add it to my y is because the x's will stay the same, but I'm just moving the point upward, which affects the y. So the focus is at 6, 7.